So let's look at this one. This one's not too, we'll look at some easier ones and some harder ones. So we're going to graph the zero isoclines, also called the nullclines. So just to kind of remind you that sometimes people call these different names, and show that 1, 1 is an equilibrium. And then we're going to use graphical method to classify stability. Okay, so here's our system of differential equations. We have dx dt equal to 2x minus x squared minus xy. And we have dy dt equal to xy minus y. So first off, we're going to find the null lines. And I really do think two things. I mean, I think more than two things. Two specific things here. It's good to use different colors for x and y. So I'm going to use green for x, red for y. And it's good to call the dx dt your f and your dy dt your g. Obviously, you can use F1 and F2 if you feel like you need to do that instead.
What does it say? Graphical upload?
Method. Promise, it says method to classify stability. So let's find the nullclines first. So we're going to set x 2x minus x squared minus xy equal to 0. And again, when you're doing this, you want to try and factor out as much as you can. Here I can factor out an x, so I've got x times 2 minus x minus y equal to 0. So I'm getting both x equal to 0 and 2 minus x minus y equal to 0, which results in y equal to 2 minus x. And then before I start drawing them, I'm going to also find this one. So factoring out here, I set xy minus y equal to 0. I get y times x minus 1 equal to 0. So I get y equal to 0 and x equal to 1. Cool. So now I'm going to do this. So I'm going to do the x ones in green. So x equal to 0 is the vertical axis. So I'm going to draw, here's my x equal to 0. And y equal to 0 is the horizontal axis. And then we also have y equal to 2 minus x in green. So that's going to have a y-intercept of 2, an x-intercept of also 2. And then finally, we have x equal to 1 in red. Draw that like specifically bigger, but so just as a reminder, these red ones are where dy dt is equal to 0. So dy dt equals 0, dy dt equals 0. The green ones are where dx dt equals 0. So we know that on the green ones, everything should be purely vertical. And on the red ones, everything should be purely horizontal. Okay, questions so far? Okay. We can totally see that 1, 1, we can see that 1, 1 is an equilibrium because it's where an x nullcline and a y nullcline cross. But we can also plug in 1, 1 to each equation. Right? If we plug in 1, 1 here, right, dx dt evaluated at 1, 1 is equal to 2 minus 1 minus 1, which is 0. And dy dt evaluated at 1, 1 is equal to 1 minus 1, which is 0. So let me ask both of you. I know it's kind of, so hopefully you can kind of differentiate between the red and the green, right? I think you can see the difference. Okay. How many more, I should say, how many total equilibria are there on this phase plane I'm starting to draw? 1, 2, 3, or 4?
4, I think. The red and the green cross.
Right, I think it's 3. Let's double check. So, well, I think it might, well, I'm not actually sure. So that right there, not an equilibrium, because it's where the green null line crosses another green null line. That one right there is our 1-1 equilibrium. Red crosses green. Over there, red crosses green. So we also have an equilibrium at 2-0. And then also at the origin, red crosses green. And then that one right there, not an equilibrium, because that's where red crosses red. So again, good selling point for doing things in different colors. So you can see, oh, if they're different colors in the cross, equilibrium. If they aren't. All right. So now we're going to use the graphical method at this point to kind of see what's going on. And so, how do I say this the right way? I typically like to start by plugging in some point that I know isn't on a null line. So I'm going to plug in, I'm probably just going to pick 2-2. 2-2 is easy to grab. It's way out here. It's definitely not on any of these null lines. So if I plug in 2-2, I get dx dt equal to, let's see, 2 times 2 minus 2 squared minus 2 times 2 is 4 minus 4 minus 4, which is -4. And dy dt is equal to 2 times 2 minus 2, which is 4 minus 2, which is +2. So over here at the point 2-2, I can do this a couple ways. I can either draw the arrows. I can say, all right, I'm going to be going left and up. I can also say, I know that f right. It's Friday. You can't have a bad day. You can't have a bad day on Friday. So here we know that f, which is dx dt, is negative. G, which is dy dt, is positive. Left and up. And then you basically just, every time you cross a null line of a certain type, that thing changes. So dy dt is where g is equal to 0. Dx dt is where f is equal to 0. So when I cross this null line, g is going to change signs. I'm going to go from f negative to g and g positive to f negative and g negative. So I'll be going left and down. And then I'm going to cross the x one, so then, or the f one, so then f is going to be positive, g is still going to be negative. So I'm going to be going right and down. And then over here, if I cross the green one again, I change the x one again, f is negative, g is still negative. If I cross the green one again, I'm just changing, so every time I cross the green one, I'm just changing f. So now f is not a lot of room over here. F is positive, G is still negative. And then over here, not a lot of room at all. And so right there we have, I'm just gonna draw the arrows. So if I cross this red one, Y is gonna change. So instead of being right and down, I'm going to be right and up. And we could do more, right? If I cross this Y1 here, I'm going down instead of up. If I cross this X1 here, I'm going left instead of right. If I cross this Y1 here, I'm going up instead of down. If I cross this X1 here, I'm going left instead of right. So you're only ever changing one of the directions. Right? If you're going up and right and you cross something, you better either be going up and left or down and right. You can't change completely from up and right to down and left and vice versa. Okay, I kind of want to get a little further. So looking at the point 1-1, and actually let's blow this up a little bit so it's a little easier to see what's going on here. So specifically, yeah. So here's the point 1-1. And in here we have f greater than 0, g less than 0. Over here we had both being positive. Over here we had f less than 0, g less than 0. And over here we had f less than 0, g greater than 0. Okay, so looking at that, I'm going to try and figure out what's going on with the Jacobian. I'll remind you, the Jacobian is fx, fy, gx, gy. Okay. So as we travel to the right, what's changing? X or Y? X is changing as I travel to the right. So as X changes, I'm going to look at both fx and gx. So as we go to the right, as X increases, what's happening to F? Well, we're going from a place where F is positive to a place where F is negative. So F has increased or decreased? Definitely decreased, which means the partial derivative of F with respect to X is negative. I decreased, my derivative is negative. On the other hand, as we go from left to right, the G thing is going to increase. G goes from negative to positive. So gx is going to be positive. And we can do the same thing in the y direction. Oh, that's interesting. I'm on a null line in the y direction. Well, that's okay. We can make that work. So as I go in this direction, I'm going from a region where F is positive, right? Either here or here, F is positive, to a region where F is negative. So definitely my F is going from positive to negative. It's again going to have a negative derivative. Now here's the part that always used to throw me off. As I go from here to here, G isn't changing because I'm on a Y null line. So right, this line here is the line dy dt equals 0, or if you prefer, G equals 0. If G equals 0 here and G equals 0 here, G isn't changing at all, meaning the derivative is 0. So if you're moving in the direction that's on the null line of the thing that you're asking about, its change is 0 because it's equal to 0 on that null line. So specifically, I'm moving across this equilibrium, and as I move in this direction, oh, I'm literally on the line where G equals 0. So GY has to be 0. It's kind of cool. And now we can do the trace determinant thing. Our trace is what? Well, I should say, is our trace positive or negative? Definitely, right? Negative plus 0, gotta be negative. And our determinant is 0 minus a positive or a negative, right? And so 0 minus a negative is positive. And then honestly, I like to draw this little picture. So like, I know that if my trace is negative, well, here's that picture where this is your trace and this is your determinant. And here's the line, the curve, keeping the imaginary results from the real results. So if my trace is negative, I'm over here. If I'm over on this side, and if my determinant is positive, I'm up above the x-axis. So I'm over here. And on this side, whether I'm here or here, we're stable either way. Because over here, we have a stable node, and over here, we have a stable spiral. Now, you don't have to draw this picture. I kind of like to. I haven't drawn it done, right? But we can also just use the criteria. Oh yeah, we know if the determinant's positive, you either have, well, you don't have what if your determinant's positive? You don't have a saddle if your determinant's positive. So you either have a spiral or a node. And then since the trace is negative, we know it's a stable spiral or a stable node. So I would just say we know it's stable. Let's do the same thing for 0, 0. So if I look over here instead at 0, 0, where I should probably, I'm going to copy back the rest of my graph here. So over here on this side, we had F being negative, G being negative. Over here, we had F being negative, G being positive. And over here, we had F being positive, G being positive. Oh, but I'm also on, so this, interestingly, this is on an isocline, on two isoclines, right? I mean, well, of course, they're both on two isoclines, right? Literally, the equilibrium is where two null lines meet. What I'm trying to actually say is that if we travel in either this direction or this direction, we're going to actually stay on the null line the whole time. So that's kind of what I was trying to say with in terrible words. So let's remind ourselves that this vertical line here was when f, which was dx dt, was equal to 0. And this horizontal line was when g, which is dy dt, is equal to 0. All right. So if I move from left to right, I'm trying to find fx, fy, gx, gy. If I move from left to right on the thing where y is equal to 0, or sorry, that's a g, not a y, apologies. On the thing where g is equal to 0, I know that gx should be 0 because I'm moving along the thing where g is equal to 0 in the x direction. I feel like I didn't say that very well. I'm going to say it again. So as I move along this curve, typically I look at f first. I was trying to get ahead of myself. So if I move along this curve and I ask about f is going from something being negative to something being positive, right? F is definitely positive over here. F is definitely negative over here. So we're changing in a way that we are, we're going from negative to positive, so we are increasing. And then if I look in this direction, well, in this direction, f is equal to 0. So if I move along this direction, if I move in the y direction, I ask how is f changing? It isn't. In a similar way, if I move in the x direction and I ask how g is changing, it isn't, because g is equal to 0 along this curve. And then if I move in this direction and ask how g is changing, well, g is going from positive to negative, so it is decreasing. Here we definitely have a saddle. Our determinant is negative. Our trace, actually, we don't know what our trace is. Could be positive or negative. Doesn't matter though. Determinant's negative. We have a saddle situation. We have instability. I suppose we should also look at the last one. Last one, which was 2, 0 over here. So I'm going to run out of room. So this was for 0, 0. Now we're going to look at 2, 0. Okay, so I suppose I need to fill out the rest of this. So again, right, this being y g equals 0 means from here to here, g is going to change, f is going to stay the same. And then this line being one where f was 0, we go from here to here, f is going to change, g is going to stay the same. Okay, so once again, moving in the x direction. So let me ask you both. Let me ask you this. I'm asking you both. If I move in the x direction, is f increasing, decreasing, or 0? I should say. No, that's right. Yeah, that's fair. F is decreasing, right? Because both the f's are positive on this side, both the f's are negative on this side. It's kind of weird when you're on the line, right? This is when it would actually probably be like good to draw the arrows on the line. Be like, oh yeah, I know that along this line, my arrows are actually moving in this direction. I've actually started drawing the phase plane. So we are going from negative to positive, we are increasing. And then if you move in the vertical direction, f is going from positive to negative. So f is decreasing. Same deal for g. For g, if we move in the x direction, well, in the x direction, g is 0 the whole time. So g isn't changing. And then finally, in the y direction, g is going from negative to positive, so g is increasing. Okay, what's my trace? Positive or negative? Definitely positive. And my determinant is also positive because it's a positive minus 0. So we definitely have instability. Right? Just as a matter of fact, right? For this one, we would be over here in this section, where either here you'd have an unstable node or here you'd have an unstable spiral. Okay. Questions? Other questions I might ask. So it's kind of interesting, right? So here at 1, 1, we have stability. Okay, erase the 1, 1, 1. Right. Yeah, sorry, that's at 1, 1. At 0, 0, we have an unstable thing. This is the second time in here that this is just kind of closed for some reason. I don't know what is going on with that. That is very strange. Sorry about that. 1 second. Sharing the screen. It's so strange. So other things you could do with this. You could do it analytically, right? You could totally, instead of having done all this, we could go back to our original system of equations and actually find the Jacobian. So, oh yeah, someone was asking me this earlier today and they were getting really, they're like, I can't find the Jacobian because I don't know what the equilibrium is. You don't have to know an equilibrium to find a Jacobian in general, right? The Jacobian very generally is just the matrix of partial derivatives. So if I want to find the Jacobian here, it would be 2 minus 2x minus y. And then it would be, let's see, here it would be negative x. And then down here it would be the partial derivative x would be y. And then it would be x minus 1. So you can totally find the Jacobian for this system of equations and then do the things, right? You could totally plug in 0, 0 and get the matrix 2, 0, 0, negative 1 and see that you have a saddle there. And you can totally plug in the point 1, 1. You get 2 minus 2 minus 1 minus 1, 1, 0. And see that you have, let's see, we actually have to work for this one. I don't really want to work that hard. The trace is negative, and the determinant is 0 minus minus 1 is positive. So it's definitely stable there, like we said it was. You could go further in your analysis here and say you have something that's more like a stable spiral or something that's more like a stable node by actually finding the eigenvalues. And so to do that, we would have lambda squared plus lambda minus 1 equal to 0. And you would get real eigenvalues there. But sometimes we get asked questions where we're not given the actual system of equations. So for example, let's say we had the following situation. Let's say we're going to, always with the, we're going to assume that dx1 dt is equal to a function of x1 and x2. So we're just calling dx1 dt f like we often do. And dx2 dt is equal to g as a function of x1 and x2. And we are going to be given the null clients. And we're also going to assume that both F and G increase close to the origin. And as we will almost always assume in this class, both change signs when crossing their isoclines or nullclines. I should really be saying nullcline. If you say isocline, you should say it's the zero isocline, because an isocline can be any line where your derivative is equal to a constant value. We care about the ones where it's equal to 0. So here is our drawing. Let's see. Sure. Yeah, I want just that. So here is my G null line. This is where G equals 0, or if you prefer, dx2 dt equals 0. And here is my in red. So I think I might have switched colors on you guys. Here is my F null line, or my dx1 dt equals 0. So given this, we want to try to determine the stability of that equilibrium, of that point right there. So is our equilibrium stable or unstable? Well, we're going to do the same sort of thing we just did, but now we don't have any equations to work with. We really just have to. This is kind of how they force the graphical method on you. Like, here's a picture, not giving you anything else, use the graphical method. Okay. Well, we were told that both F and G increase close to the origin. Meaning over here, close to the origin, both F increase. I think that's what I meant to write. I think really what I meant to have said, and I apologize, is that both x1 and x2 increase near the origin. Because if x1 and x2 increase, I feel like the wording on this is not what I want. Let me think for just 1 second here. If f is dx1, x1 is increasing, then f would be, the derivative of x1 would be positive. Yeah, no, I think that's what I should have actually said. I'm sorry. So I should have actually said with x1 and x2 increase close to the origin, meaning that dx1 dt is positive because x1 is increasing, and dx2 dt is positive because x2 is increasing. So over here we have that f is greater than 0 and g is greater than 0. Essentially, the point of that is to give you some sort of way of determining what's happening somewhere. Right? I could have said, I think in the book they phrase it like, all the points under this curve have, an increasing y value or a decreasing x value or something like that. They kind of try to, there was one problem I was helping someone with where the phrasing was very, very unclear. It was like all the things less than this, but it wasn't sure if it was like less to the left or less under. And so, yeah, it can be a little challenging. So if we have this, now we can kind of figure out what's going on with the rest of these. So I also do like to draw the arrows. If F and G are both positive, we know we're going up and to the right. And then when we cross G, what's going to change? F or G. Right, when you cross the thing, that's the thing that changes. So F is still positive, but now G is negative. So we're still going right, but now we're going right and down. Okay. Oh, this, yeah, we're gonna make this, yeah, I like this, okay. So then up here, when we cross F, well, F's gonna change, and we're going to have F being negative and G being negative. So we're gonna be now going down to the left. And finally, over here, G is going to change again. We're going to have F being negative, G being positive. So we're going to be going left into the up, left and up and left. And then one other thing you can do to kind of help your picture out is to actually draw the vertical or horizontal lines on the null lines. So on this red null line where dx1 dt is 0, meaning the change in the x direction is 0, all my arrows are vertical. Oh, question.
Yeah, so that last one that you just did,
Uh-huh. Did I blow it?
no, I'm just wondering
Okay.
why you went like bottom to top instead of from the where why you didn't do like F is negative on this side and then switch it to positive.
So from where to where? From here to here?
Yeah.
Because I'm crossing a G null line. No, but the fair, you were not as like, it's a hard thing to do, right? This is taking me a couple years to really like fully wrap my head around all the time. And be like, oh yeah, I totally know what I'm doing every time. Like it works. It takes effort to see what's going on. You guys are definitely doing a much better job than I did the first time I saw this. I was like, I have no clue how this graphical method works. What is going on? Okay, so one other thing we can do is we can also draw the arrows on the null lines. On this red null line, where dx1 dt equals 0, which way should my arrows go? Up, down, or left, right? So here's another way to see it. If you've already done this part, my arrows over here are going down and left. My arrows over here are going down and right. I can't be going right or left over here because I'm going left here and right here, but you can totally be going straight down. So here we're definitely going down. Over on this side, we're going up. And what's kind of neat is you can actually start to kind of see the trajectory, right? Like if I started at a point here and be like, well, I'm going to have to go up and to the right, but then I'm going to have to like cross that in a vertical way and then start going up and to the left. Or if I'm further over here and I start going this way, and then I have to cross this in a purely horizontal way, right? Because this is definitely everything moving to the right. And over here, everything's moving to the left. And be like, oh yeah, I'm going to cross this purely horizontally and then start going that way. So even just drawing these trajectories, I'm kind of thinking, I probably have a saddle. It's looking very saddly. That's a word, right? Yeah. But we can also use the graphical method to see if we have a saddle or something that's like a saddle. So, all right, we're going to do the usual things. I'm going to start here and I'm going to go to the right. So my Jacobian is looking like, as I move from left to right, I really think, I know it's hard to remember what's what. I think when you do this graphical method, if you have to do this graphical method, you should just quickly write out what the Jacobian is. And I don't think he would enforce you having to use F1 and F2 and X1 and X2. I would use F's and G's and X's and Y's, right? It's just less gross looking. So then, as I move from left to right, how is F changing? Is it changing? Am I on the line where F equals 0 or where G equals 0? So F isn't changing. So as I move from left to right, F isn't changing. As I move from bottom to top, F is going from positive to negative. So it's definitely decreasing. And now as I move from left to right, I ask about G. Okay, well, over here we are going up, over here we are going, that's why it's also good to draw these arrows on the null line, because if you happen to be traveling exactly on the null line, you'd be like, oh, well, here we were going up, here we were going down, so we must have gone from positive to negative. Or you can see, right, over here, all the G's are positive, over here, all the G's are negative. But actually, it's kind of cool drawing these lines because here you'd be like, oh, well, along if I'm going up, 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 and then down, 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 well, my F, which is the change in X1, didn't change at all, right? F was not going left or right, not going left or right, so its change is 0. So you can see that too. And then finally, as we go from bottom to top, G goes from positive to negative, so it's going to be negative. Okay, so let's see, our trace is negative. Our determinant is, what is our determinant? Yeah. So are we stable or unstable? Oh, So here's what I would say, right? So let's make sure we've done this analysis correctly. I think we have. If we look at this here, we've got
Isn't it like a saddle?
well, no, it's not a saddle. If the determinant's positive, it's we have like something more like a sink or a stable. We have something stable. And it might be a stable node, it might be a stable spiral. So I will point out, sometimes my drawings just aren't good. I kind of feel like, I'm kind of curious about why this looks, I kind of want to know more now. Let me make sure I didn't draw anything really, really dumbly, because sometimes that happens. Because I really feel like this doesn't, I mean, you guys, I think we were in agreement. This looked pretty saddly here. Let's see if these are both positive. Do that. And then if we go over here, G changes, go over here, F should change.